Hi, hello everybody. So this is the video dealing with section 2.7, polynomial and rational inequalities. And this is the second part where we focus on the solving rational inequalities. Now, in the previous video, we solved polynomial inequalities, and solving rational inequalities is almost identical to solving the polynomial inequality. So we're going to have, instead of a polynomial expression, we're going to have a rational expression. So what is a rational expression? It's just a ratio of two polynomials. So if Rx is a rational function or rational expression, it's just a ratio of two polynomials. So you have a polynomial on the numerator and you have a polynomial on the denominator. And because it's an inequality, instead of the equal sign, I am going to have again one of these four inequality symbols. Now we're going to solve it the exact same way. We're going to set the inequality to zero. So we're going to have one of these four symbols and zero on the right. We're going to then completely factor the polynomial on the left side. We're going to then, once it's fully factored by one of the known factoring techniques that we've discussed before, we're going to set each factor equals to zero, solve for x, just as we did before. Now, as before, we tested a value in every segment of the solution set that we got. Now, this is also the same. We're going to have to do that with one exception. And here's the one exception. It's right here. Okay? So we'll solve the exact same way as we did the polynomial inequalities with one exception. All denominator factors need to be excluded from the solution. Okay, and here's the reason why. So let's imagine, for example, I factor my solution, and maybe I have something like this. Okay, here's the denominator factor. When I set it to zero and solve for x, I obviously get x equals 5, which is, one of the roots. The problem is, if I grab this 5 and I put it over here, what am I going to get? I'm going to get division by 0. So that is not allowed. Regardless of what the symbol is here, with or without the equal sign, all denominator factors need to be excluded from the solution. So this is extremely important. You cannot forget. Okay? So all denominator factors need to be excluded from the solution. So whatever the root of the denominator is, it needs to be excluded. We still have to find a value, between the roots, which is okay, but, the factor itself needs to be excluded, regardless of whatever symbol we have. Okay, so so I have two examples just as before, and we'll make this thing a little bit smaller, and we'll do each case for you to see. All right, so let's do the first one first. So remember, our first step is to make sure that we have 0 on the right side. So in this case, I need to subtract it by 2. So this is my starting point. Now you have to remember how to solve these, rational equations, if you will. So we have to find a common denominator. Well, the common denominator is x plus 3. Okay, now again, I'm not reviewing solving, rational equations, but you could review that, with the material from Math 119. So the common denominator is x plus 3. So the negative 2 was already there, but so if you added the x plus 3 on the denominator, you have to add it also on the numerator. Okay? So now this fraction remains the same, because if I were to cancel the x plus 3 and x plus 3, I end up with the minus 2 again. So this is correct. Now that I have a common denominator, you are going to combine the two fractions into one, okay? Now, in the numerator, I have x plus 1 minus, and obviously distribute the negative 2. Negative 2x minus 6, right? It's negative 2 right here times the positive 3. Combine like terms. So I have x and minus 2x minus x, positive 1 minus 6 minus 5. And I have x plus 3 right there. All right, at this point, the rational part of the inequality is fully factored. I'm going to now use the zero product rule, and I'm going to set each factor to 0 just as before, and I'm going to solve it for x. Okay, so I'm going to add 5 to both sides. You could have just added the x, but it's okay. And then I'm going to divide everything by negative 1. I get x equals negative 5. This is one root. Minus 3 on both sides. This is another, supposedly, right? Now, I am going to do just as before at this point. I got the roots. This one is not really a root, but I'm going to call it a root now because the procedure seems very similar to the polynomial inequality. So this one is not a root, and I'm going to tell you why in a minute. Okay, draw the real line, right? Put the 0 in and put the two roots in. So negative 5 and negative 3. Okay, so let's indicate that this is a root and the division of the areas. So again, I have one segment here. I'm going to call it 1. This is the second segment. And this is the third segment. I have to check all 3 segments, and I'm going to pick a number. I'm going to pick a number in each of these segments. So I need a number in segment 3 smaller than negative 5. So I'm going to say negative 10. In segment 1, I'm going to pick 0 because it's easy. And in this segment 2, I'm going to pick negative 4, right? So I have my 3 numbers. I have to check all 3. So 0, negative 4, and negative 10. All right, so let's do the 0. And you are going to test in the polynomial or inequality, rational inequality, that is fully factored. Don't test it here. Don't test it in the original. Test it in the fully factored one. So minus 0, obviously 0, minus 5, divided by 0 plus 3, 0. Put the symbol in. So all you have to know, you don't have to do the division here. All you have to know is if negative 5 over 3 is greater than or equal to 0. Obviously not. False, right? Because negative 5 over 3 is a negative number. So this is false. So the solution is not here. I'm going to check the negative 10. So same thing, negative 10. Now, be careful, right? So it's negative 10 minus 5. So this is 10 minus 5, which is 5. And negative 10 plus 3. Oh, I'm sorry, this is supposed to be on the 10, right? On the other segment. Okay, right here. So negative 10 is positive 10 minus 5, 5. And negative 10 plus 3, negative 7. Is it greater than or equal to 0? No, obviously not, right? We'll move the minus up, so it's minus 5 over 7, which is obviously a negative number. So the solution is not here. Now let's check the negative 4. So same thing, negative 4 minus 5. So this is positive 4 minus 5 is minus 1 over negative 4 plus 3 is also minus 1. Yes, the both negative signs cancel each other out. So I have 1. It is greater than 0, so this is true. So the solution is here. Okay. So the solution is only here in this interval. Now, okay, so this is number 1. We got a solution partially, but notice this is an equal sign. Now, what does that mean? It means that normally you would include both endpoints from negative 5 to negative 3 because of the equal sign, right? But I told you before, what happens if you include the negative 3 here? Okay, so let me just erase this for a little bit. What happens if you include negative 3 here? So you have negative 3 plus 3, which is 0. So I cannot have division by 0. So on the denominator root, whatever the sign is, you cannot include. So the minus 5 is included. That's why you have the square bracket. And the minus 3 not included. That's why you have the parentheses. So the solution is this. So this is very important. All denominator factors have to be excluded from the solution. All right? So this is the first one. So this is the first problem. All right, so let's do the second one. I'm going to erase this so that we have a clean environment to work with. And let's do the second one, which is identically done as the first. So first, I need to make sure that I have 0 on the right, so minus 1 on both sides. So 2x, x plus 1 minus 1 greater than or equal to 0. Same thing as before, find the common denominator, which is x plus 1. And if you included the denominator here, you must include it in the numerator. Otherwise, you've changed the rational expression. Now, once you have a common denominator, combine it as a single fraction. Distribute the minus 1. So minus x minus 1 greater than or equal to 0. Combine like terms right here. So I have 2x minus x is just x minus 1 and x plus 1. So this is now my fully factored rational expression or rational inequality. Okay, so I'm going to, by the zero product rule, solve each equation with the 0, with the equal 0, because I need to find the roots. So plus 1. So this is one of the roots. Minus 1. This is the other root. But remember, right? The denominator is never a root. So this value, even though now we're calling it a root, this has to be excluded later. So now I'm going to do the testing. Positive infinity. Put a 0 here. I have a positive 1 and negative 1. So here's negative 1. Here's positive 1. Let's divide so that you can see the division. The 3 segments. Here is my segment 1. Doesn't really matter which one you call segment 1, 2, or 3. I'm just doing this for your notes. And I have three segments, which means I have to pick 3 points in each segment to test the value. So in here, maybe I'm going to pick -7. Here, I'm also going to pick 0 again. So it has to be a value in the segment. And here, I'm going to pick, I don't know, 5. So now I have to test all three values to see if they satisfy the original inequality, but in factor form. So I'm going to test, right? So I'm going to test the -7, I'm going to test the 0, and I'm going to test the 5. Using the factored rational expression. So let's see. So -7 minus 1, -8. -7 plus 1, -6. Write the symbol and see if this is true. So the two negatives cancel each other, and I have 8/6. Yes, it's positive. So this is a solution in that interval. Now I'm going to check the 5. All right, so again, 5 minus 1, 4, over 5 plus 1, 6. Is it greater than 0? Yes, it is true. So there's also a solution here. Now let's check this 0. Again, using the factored form. So 0 minus 1 is -1. 0 plus 1 is 1. So is -1/1 greater than 0? No, that's false, right? -1/1 is -1, so that's false. So there's no solution here. So the solution, so then we write, I'm going to shade it where the solution lives. It lives in the segment of -7 and 5. So here's the solution, and here's the solution. So I'm going to have two intervals that I'm going to have to write, okay? But keeping in mind that -1 is going to be excluded. So let's do this interval first. So this goes from -∞ to -1. And even though you have an equal sign here, right, the -1 cannot be included. You cannot put a square bracket here. And for this interval now, from 1 to +∞, you do include the 1, right? Because of the equal sign. If there was no equal sign, I would write this. But because there is an equal sign, we use the square bracket. Okay? So let me just clean up this a little bit. So this is the solution to our problem. Remember, the solution to both rational inequalities and polynomial inequalities has to be in interval notation. Okay? So for rational inequalities, we are always going to remove the denominator factor, always, and write the final solution in interval notation.